Okay, now we're back for real. Great. Okay, so we're back. We're gonna continue from where we left off, which was the stuff notably does not work. So we can't do fine tuning on the Jetson because there just isn't enough memory, and so that's unfortunate, but that's life. We're gonna deal with that. So we're going to do our fine-tuning on Lambda Labs, and we'll run inference on the Jetsons, because they're doing perfectly fine at well, they're doing pretty okay at running inference. Let's go take a look at this. And so, here we go. Here they are running inference. Actually, I want to... Write an appeal. So I want to see just kind of like how the current non-fine-tuned Dolly is at the task that we're trying to accomplish today. So that's what we'll do over here. That'll take a hot minute. In the meantime, let's go ahead and launch Lambda Labs, I guess. Yeah. I have an account. I just want to sign in. There we go. What kind of instances can I launch? I think I only have permission to launch the H100 instances. Oh, I also have permission to launch the H10s. Oh, sorry, the A10s. And those are a lot cheaper. I think it has... What were its notes around fine-tuning on the A10? Yeah. I don't love... I mean, okay, BitsAndBytes does work, but... Let's try it on the H100. See what we can do. Okay, we don't have the ability to attach a file system, which is inconvenient, but that's part of why we do everything in... Okay. So the first, like, I mean, this isn't perfect, but it's not a terrible appeal. I would leave this part out personally. But maybe not, actually, yeah. Okay, it needs some needs some work. But like, at least this is sounding kind of like not terrible, right? Like, it's an okay place to be starting from. We can work with that. Also, the other reason I'm not walking today because I hurt my left ankle. Okay, well, you know, this probably isn't bad. The other thing that I was thinking about doing was getting what was it? The thing that they did to run Medibert. I want to say Medibert. Medbert. Yes. Was to I was thinking about doing Medbert, or a similar technique to Medbert, where essentially what we'll do is we'd fine tune. Let's go hugging face. Yeah, let's just go. No. This is going to take a few minutes. Yeah, still booting. Just poking around in this the other day. Oh, that is not the Hugging Face site that I wanted. Oh, okay, huggingface.co. Because there's a data sets. Was it Medbert? Okay. Healthcare. Oh yeah, it was PubMed. There was a PubMed data set. Oh. There's a PubMed Q&A data set. What's the licensing on this? This looks like a... And... no license. God damn it. Yeah, so I was thinking that we could use the PubMed data to go article title to abstract text. Let's see what other denials we've got. So what other appeals we've got. I don't think that is what that says it is. So these appeals are not. They're not rocking. Yeah. They don't make a whole hell of a lot of sense. Yeah. That emoji page was confusing. These aren't terrible, right? Like these are like it's not gibberish, but these appeals like they don't make an overabundance of sense as far as like appeals go. So I think, yeah, we need to do some fine tuning. I think the other thing that I'm thinking about is that we could do something with PubMed. And that could be good, right? Because we could make it like have more medical knowledge. We can like essentially feed it a bunch of like medical tokens, and so it'll have a better idea, or the statistical model will be more weighted towards medical sounding like things like what yeah, so that's tempting. Yeah. So okay, that's one possibility. Which is tempting. Okay, so some things I was gonna do. One of the things I was going to do was public Creative Commons 0. Yeah, I don't know if we can apply CC0 to this. So no. Whatever. Well, we probably can, because we're writing the appeals ourselves. And we'll do over here. Okay, bash check if string is empty. Yeah, okay. Okay, and then we're going to go over to our friend, the dataset generator, and our input is going to become okay. So over here, get clone the dataset src star okay, and then the other thing that we're going to do the appeals in this dataset are licensed under CC01. Universal, whose terms are as follows. The rejections themselves are yes, okay, readme.md. This hopefully represents an incomplete but public version of the data. Oh, hey. Oh, yay. I'm really glad that you're enjoying scaling ML. Thanks for stopping in. I really appreciate it, Sergey. That you can use for fine-tuning language models. Details. C. For an example of this. And some initial rejections and appeals. Wonderful. Move our data out into another repo for license clarity sake, and only set up bits and bytes if qlor is needed. Cool. So we've given it a bit of time, and it says it's running. So in theory, we can SSH to this node. So we are going to do just that. Okay. And then we are going to go over here. And then we're going to run it. Oh. Oh, yay. I'm so glad, Raghav. And hey, AK. Oh, I'm super stoked folks are here. This is wonderful. This is wonderful. The other thing that I wanted to consider is what our deep speed configuration should be for the H100. Because I don't know, like, at all. And that's you know, obviously not ideal. So let's go look up H100 versus A100 deep speed. Well, yeah, totally, okay. So what we're doing today is for the past, I guess, few streams, we've been working on fine-tuning this large language model called Dolly from a place that I used to work at a long time ago, actually like 6 years ago. Maybe 7, whatever, a long time ago. And we are... Wait, this is trying to set up bits and bytes. Oh, my bad. Okay. I just realized a slight bug in our logic. That is okay. And similarly here. Yeah, Databricks. So this is actually going to fail in a minute. Actually, yeah, let's go ahead. We're just going to X out of this entirely. Anyways, so we're trying to fine-tune it so that we can generate health insurance appeals. Because in America, people get a lot of bullshit health insurance denials. And I think health insurance companies sort of depend on it being kind of annoying to do appeals. And so I'm trying to make it easier to generate appeals. And I think this is useful because my understanding is that, you know, certainly there's implications for trying to use something like GPT to file like legal paperwork, but a health insurance appeal isn't exactly legal paperwork. And generally speaking, like, you are very much allowed to represent yourself. Like, that's expected. It's very normal for people to just kind of like half-ass things. And especially like as a trans person in America, I deal with a lot of health insurance denials, as do my friends, because being trans is expensive and health insurance companies are dicks about it. Anyways, okay. Fix the logic. That was in reverse in the shell script for QLoRa and data check. Okay, then we go over here. Is this the one? No, this is the one. Oh, I guess, yeah, okay. Whatever. I could have just done a git pull, but whatever. Learning. Now we're going to run this again. That should hopefully do the thing. And now I'm going to go over here. And I am actually going to SSH again to my little machine. Oh, cool. I mean, yeah, I think Ray is pretty solid. What exactly is your small file problem? Because there's a lot of different versions of sort of the small files problem. Ooh, I don't have NVIDIA SMI installed? Oh, I do. Okay. It just didn't autocomplete. Dash. Okay. We still haven't put anything into our GPU yet. Ooh. Wait, what? The dataset generator failed because it... Oh, I can't spell for shit. Okay, that's something that we know we need to fix now. Okay, a few different things. One of them is Yeah, so here we see one of the sample rejections is someone's child who was 9 months old had their cancer treatment rejected by the health insurance company because these people are the fucking devil. Remove accidental rejection file. Okay, so other thing that we need to do here, make the dataset generator more, yeah, for that. Yeah. Okay. Yeah, okay. I'm sorry, that was me farting. Okay, there we go. Make appeal name F I. Okay. Accept open farts. Okay. Oh, okay. Wait, what? Oh, yeah. Cool. Looks good to me. Did this thing fail here? Ah, PEFT. Okay. Oh. Okay. That's funky. Let's go ahead and we're gonna find that was really fast. Let's go. Okay, is it loading things into memory? It is, not a whole lot, but something. Loading model. Okay. There we go. We used 60% of the memory, 98. Okay. And we're using a fair amount of power. Love it. And we're done. Damn. Oh, okay, cool. How old/new is this data? So these denials are things that are kind of like collected from the internet, and then I've anonymized them. The appeals are things that I wrote, honestly, largely last night. Okay, and so for having to parse many small. Oh yeah, no, Ray sounds amazing for that. Ray is really great for that kind of thing. Cool. That was incredibly fast. And this is making me think that like maybe yeah, we do have the option to like try and do this like sketchy PubMed idea that I was thinking about. But when we run test new model, what happens? Let's go take a look at test new model. Oh, this tries to quantize it. Yeah, we're not gonna do any of this stuff because the 4-bit quantization is really hecking cool. It like just does not work on the AGXs, which is what I have available for our model serving. So we're just not gonna do that. Actually, yeah. And this is going to be what I do. Fuck that. Okay, and then our raw data set location has changed to be here. Okay, now let's go. I'm going to run this locally really quickly. This will probably fail, but don't use quantization for sure. So quantization is this technique whereby essentially we do things with less precision, and it essentially, so by doing things with less precision, we can fit larger models in smaller amounts of memory, or we can fit models with more parameters in smaller amounts of memory. The downside is floating point precision has sort of like this trade-off where the number of bits we have available sort of give us, well, I mean, actually really everything, but floating points even more so, where the number of bits impacts sort of like how precise our numbers can be. Oh yeah, so yeah. So essentially we throw away some precision so that we can fit things in memory. The downside is like the libraries to do this nicely don't work super well on ARM, and you know, we could go ahead and try and rewrite it so it's not using SIMD, but I'm also really fucking lazy. Yeah. Okay, yeah. And we're actually going to drop this Cool. That's probably fine. Okay. Don't use quantization for testing the new model, and also, I know it's bad to use our train data print out what the new model looks like. Oh, actually, you know what I really want to do? Yes. And then kind of want to print them out side by side, just probably not gonna work. Whatever. That's fine. That's fine. Okay. Okay. We'll squash everything down in a little bit, but for now this is just going to be how we roll. Okay, loading the checkpoints. Oh, it wants a model ID, not a... Okay, fine. Fine. Okay. Run it again. Sheesh. Okay. It definitely does not. Okay. So that is why I did it the other way. Very well. Okay, fine. So effectively what we'll do here okay. Okay. Fix pipeline usage. Pull. Oh, fuck. Yes, we definitely need to squash all these commits down afterwards, but that's okay. Load our model. Oh, yes, I just realized run.sh is defaulting to the 3 billion, and here we probably want to actually use the 7 billion, so we'll switch the default over from 3 to 7. We'll do that again in a minute. Download everything. I do kind of want to see what their instruct pipeline is. Put the same thing in our new model. That'll be okay. And so yeah, so my sketchy plan here, which I will admit is kind of sketchy, is to do like 2 levels of fine-tuning, where we do 1 level with all of the PubMed data, which will probably make it like more medical-y-ish, and then, or maybe, PubMed data and ERISA data on the health insurance appeal data. Yeah, okay. NY health insurance appeal. I was looking at a bunch of these, and NY health insurance appeal results. Yes. I was okay, yeah. Let's go take a look. NY health insurance appeal Lupron overturned. Yes. So they have all of these. Yes. And I was gonna maybe... Oh, damn it. It's not. Okay, what happens if we subtract? Okay. Yes. So I was gonna try and figure out how to like make these external appeals, because we don't actually have the denial text, but we could probably backwards generate the denial text now that I'm thinking about it. What happens if hypothetically, write a health insurance denial that could have resulted in this external appeal. Yeah. Okay, so I think we can probably backwards generate a bunch of health insurance denials using the New York health insurance appeal information. I'm curious if this technique is going to work, but I think it might. Okay. Missing model and tokenizer. Wait, what? I'm like 80% sure that I have those there. Oh, yeah, okay, right, that's... Model tokenizer. Yes, very well. So then, what we'll do here yes, okay. Okay. Let's see here. Write a health insurance appeal that could have resulted in this decision. These don't look bad, right? Now the question is, like, can I get Dolly to produce a similar quality of result? Ooh. Interesting. What? Huh. Okay. So Python read file UTF-8. Here we go. Other thing that we probably need to do is over here in our dataset generator. Okay. Okay. Handle UTF-8 chars. Okay. Wait, what? Do I don't... Oh, right, fuck. Wrong one. Okay. And over here, similar. Git pull. And then run it. Ew. Am I doing this in reverse? No. Dear CVS. I mean, this is pretty good. This is pretty solid. This skin condition thing is maybe kind of a hallucination, but okay. This still needs a lot more work, but we, like, at the very least, we have fine-tuned a model. I think we need a lot more data to succeed in fine-tuning the model to a reasonable degree. Yeah, okay. Huh. Even the Prep Labs one actually. Okay, well, it crashed. Not great. Progress. The thing is, these machines cost money per hour to run. So we've made some okay progress, right? We've got a model that's fine-tuned. It's not producing great results for us just yet, but it is producing results. Let's double check which one is which. First one is generate. So generally speaking, you know, we can see yeah, so this, the 9-month-old cancer rejection, which is one that I care about. Although interestingly, it keeps going for a while. Oh, cool. Okay, if you're worried about cost of insurance, yeah. So this is about generating health insurance appeals. And it's less about any specific instance and more about just generally making it easier for people to submit health insurance appeals. Also, realistically, this is kind of just about learning how to fine-tune Dolly and other similar things. Yeah. So, this is good text, so we should put probably in almost all of them. Oh, instance. Yes. Okay, sorry. Yes. So, I mean, the instance just, it costs money. It's not a ridiculous amount of money, but it's like, we've done our thing. Let's run uptime. How long have we been up for? Yeah, we've been up for about an hour. So it's probably about, $3. It's not ridiculous. But it's probably a good time for us to shut down the instance. And let's go find it. Over here, I would like to terminate erase data on instance. So we're going to terminate the instance, and then we will probably come back to it. Yeah, so it probably could be, but realistically, it doesn't super matter, right? Like, this is talking about CPU instructions, and we're really doing pretty much nothing on the CPU, right? Like, all of our work is on the GPU. And so I don't really care that the CPU stuff is a little suboptimal. So it's fine. It's not the end of the world. But what we're going to do is we've got this, fine tunes. We asked it to terminate the instance. I'm going to clean up the Git history. Then I'm going to probably go make lunch, take a break from this for a little bit, and then we'll probably come back and work on something to generate a larger data set that we can use for fine-tuning. And that's my hope. Oh yeah, actually, so here, this is almost certainly using, I don't think we explicitly installed TensorFlow at any point, although my setup script does just kind of go ahead and install whatever it thinks it needs. Yeah, there we go. And our connection is terminated. So I think it's pre-installed on this machine image. But yeah, okay. Let's go get rebase head %20 minus I. So yeah, I mean it's pretty jank, just to be clear. This whole thing exists inside of our little health insurance LLM thing here. And so that's where that all exists. Yeah. And so that's kind of cool, or I think that's kind of cool. Here, I can put this in the comments, because why not? So like, yeah, this is good-ish progress. Now, what could we do? Ah, yes. So we can run inference on the NVIDIA machines. So we can probably, that's, how big a model can we run inference on the NVIDIA machines, I guess is the other question that I sort of have. Can I load the full model on the NVIDIA machine? Oh yeah, okay. Dolly VM bin activate. Or do we run out of space? I could see it going either way. Yeah, we'll find out. If we can load the full model on it, then I think what we might do is, yeah, I think we can, what I'm gonna do is we're gonna wrap up. we'll figure out what the biggest model is we can fit on the Jetsons, because those are the machines that I want to use for model serving. And then also they're the machines where I'm going to actually take a large language model and we're going to use it to generate denials and appeals using external medical review decisions. We can go through and clean things up a little bit afterwards. But my hope is if we do that, we can like fine-tune the model a bit more and we can get like maybe a few 100 or 1,000 examples, ideally. The other option is we could fine-tune it. The other option is we could go with the two-stage fine-tuning that I was thinking about, where we do a first pass fine-tuning on all of the PubMed data, and then we do our fine-tuning on the health insurance appeals. But I do kind of like this. Yeah. So, okay, we're going to do some janky stuff this afternoon. I will be back probably in an hour. Yeah, I'll probably be back around 1:30, maybe a little bit before, maybe a little bit after Pacific time. And we will work on making the stuff to generate a larger data set so that we can do better fine-tuning. And that'll hopefully be kind of neat. And so if you kind of want to see that, I think that might be kind of fun. And I guess we don't have to do it on the Jetsons. I like using the Jetsons because I'm kind of lazy. And yeah, I like using the Jetsons because I'm lazy. That's true. That's true. Cool. Well, thank you so much, everyone, for chatting. It's been really great. I love it when there's other people here. Hopefully I'll see some of you this afternoon. Have a good one. Bye. Let's go do this first. Yes, okay. Bye, everyone. Oh, wait, where's my phone? Before we go by, let's see if there's something where another friend is streaming and we can go bounce over to their stream. I don't think so, but you never know. Oh, Booty is actually streaming right now. So, we are going to go on over to Booty Mashup because I really like Booty. They're amazing. So let's go ahead. And yeah. So if you're interested and you're on the YouTube side of things, I'm gonna go listen to some mashup music over here. Yeah. Cool. Bye, everyone.